Welcome everyone. SpaceGeekSpeak today will be dedicated to presentation uh, by Dr. Mike Gruntman. It is my pleasure to introduce Dr. Mike Gruntman, a professor and chair of astronautics at the University of Southern California. Dr. Gruntman's extraordinary career spans from growing up near the Baikonur Space Launch Base to becoming a leading space physicist, engineer, and educator. He founded USC's nationally recognized astronautical engineering program, where he has taught over 2,000 graduate students and contributed to NASA's missions, earning multiple group achievement awards. Dr. Gruntman is an accomplished author with 300 scholarly publications, including the award-winning book, Blazing the Trail, The Early History of Spacecraft and Rocketry. Today, he will share his lecture, The Road to Space, The First 1,000 Years, tracing the fascinating history of rocketry from ancient times to the dawn of the space age. Please join me in welcoming Dr. Mike Gruntman.
Thank you very
Mike?
much, Svetlana. I can move to sharing, right?
Yes. Mhm.
Yeah, and I only want to mention first that I happily dropped I was the founding chairman of the space engineering department, but I was very happy to drop it because this is an experience not much fun, shoveling administrative stuff. And then I came back again as a chair. So now, and then I left again being a chair. So I'm not a chair anymore, and I'm very, very happy. But I still run the master's program, which actually crossed the major reached the major milestone. Recently, we awarded 1,000 Master of Science degrees in astronautical engineering. So it's a really, really big. Okay, so let me just get to okay. Svetlana, is it showing the full screen?
Yes.
Okay,
Yes.
thank you very much. As Svetlana mentioned, AIAA published 20 years ago a book, Blazing the Trail. It's about the early history. It's to a significant degree, this talk is based on that, going through our historical background, how we got to space. In 1957, there was a breakthrough to space. The first satellites went up. And the story with what happened after that, in particular, such visible programs attracting public attention as Apollo program, are known pretty well to many people. However, not many know who prepared this breakthrough, what happened in the early days of rocketry, and who were those unappreciated visionary and leaders on the military side, on the state side, and the scientists and engineers who opened the way to space. So I will concentrate on that. And as usually, we would mention that 2,000 years ago, ancient Greeks were the first who sort of discovered the principle of rocket propulsion. And there was a fellow in Alexandria who who built the early pile. And the sketch is shown in the middle, but on the right, for the first time, I discovered that in one of the museums in Athens, Greece, there is they built up a model of this device, how it might have looked like. It's on the right, being shown on the right. And the steam, hot water vapor steam, was leaving tubes, orifices, or you could think about as nozzles, and created a rotary movement. However, the Greeks did not really move to practical applications of such devices or the principle. And it became sort of forgotten. And then 1,000 years later, rocketry appears in China. And one thing that, and these were solid propellant rockets, and the black powder was the propellant. Now, when it happened, we really do not know. And the reason is very interesting, that in the beginning, Chinese warriors were shooting arrows with some from irregular bows with some incendiary substances attached to the tips of the arrows. And sometime during the development of technology, they finally, let me start my pointer, maybe it will be seen occasionally. And sometime during this development, they started to attach small cases filled by the burning substance. And in that case, the arrow became a self-propelled arrow, a rocket. But we don't know when exactly it happened, because in the Chinese language, a fire arrow, that means the arrow with the incendiary substance on its tip, and the fire arrow is shown on this figure, self-propelled, they are described by the same word in Chinese. I cannot pronounce it properly, so I won't try. So it's a fire arrow literal translation in English. So if you look in the records, you couldn't really tell when it happened because it was the same word. But we certainly know that at 1232, there was a major use of rocketry in a certain military battle in China, and the rockets remained very small. Bamboo shafts for guiding were couple feet at most long, and these rockets flew 300 to 400 yards or meters. Now, the Chinese excelled in multiple launches. So these rockets were not accurate, didn't do much damage, but they were sometimes scared the cavalry or were used as incendiary weapons. But the Chinese excelled in multiple launches, creating baskets and boxes filled with multiple rockets carried by soldiers. So this was a development. But we will see in a moment that in India, there was also very serious development in rocketry. And the old question, who was the first, we really do not know. It is certain that the Chinese rockets or Chinese records about rockets are the oldest. And in India, rocketry did exist in these old times, but we don't have records. Now, why did it happen in China and India? Rockets were powered by gunpowder, or the early versions of gunpowder, the black powder, which is a combination of charcoal, sulfur, and saltpeter. Charcoal is everywhere. Sulfur is also very well known in all countries. However, saltpeter is naturally abundant in China and India, but practically none of it in Europe. Only in Sicily, in some places, there were places where one could get saltpeter. It had to be produced artificially. So because it's naturally abundant in China and India, it was the Indians and Chinese who really became the first who developed black powder and then rocketry. As a typical historical story goes, that the Mongols overran China, took over the Chinese technology, including rocketry, and then Mongolian troops took it to other countries. This was the first wave of proliferation of rocket or missile technology, and the troops took it to Japan, to Korea, to Java, Baghdad. There was some historical records that are saying that Baghdad was attacked by rockets, but it's questionable. We don't know for sure. And certainly Mongolian troops used rockets in Europe in the Battle of Legnica in 1241. It's in today's Poland. They could have taken it also to India, but it also could have been indigenous development in India. In a moment, you will see why I'm saying that. So the story is that Mongols brought gunpowder and rockets to Near East and taught the Arabs and the Europeans. This is not exactly well founded, because in Europe, in the Byzantine Empire, there were independently known incendiary and explosive devices for several centuries before that time. The Greek fire was a major potent weapon for the Byzantine navy in the 6th or 7th century. And there was a fellow also, Marcus Gracchus, or Mark the Greek, who described gunpowder-like mixtures and projectiles in the 9th century. So we really do not know. There was no archival journals at that time, so we do not know what really was happening there. And there was some exchange, obviously, of technology between faraway countries, but not necessarily a very on a large scale. We know that in Europe, the French established a facility to research in saltpeter in Paris in 1227. So it's basically explosives. And then the Crusaders were encountered with some rocket-propelled devices during the Crusades in the Middle East. And at that time, medieval times in Europe, the rich Italian cities, Venice, Genoa, Pisa, led the technology development. They took advantage, these cities, of their position at the crossroads and exchange of trade between Europe, continental Europe, and Orient through Middle East, stretching to India and China. But we know for sure there are historical records that the first time rockets were used in the European warfare in 1379 in Italy. And the figure on the right shows these primitive rockets and a fellow who is igniting the rocket projectile to shoot at a castle ahead. He better step aside after igniting not to get hurt by exhaust. So now we're getting to India. Remember, the first certain use of rockets in China, it's 1240. In India, there's a first official record that we have is 1399. And it is actually the memoirs by great warrior Timur or Tamerlane, who led the troops who invaded India. There was a famous Battle of Delhi in 1399 where Tamerlane troops finally overran the Indian resistance. And this warlord describes that Indian troops that fought against them had 125 elephants covered with armor, most of them carrying howdahs. And a howdah is this box sitting on top of the elephant for people, in which were meant to hurl grenades, fireworks, and rockets. So the rocketry was known for a long, long time in India. And by the 18th century, the rocketry truly proliferated among Indian states and potentates. Saltpeter abundant, bamboo also available that made very nice, light, straight guiding sticks. And another very important thing, the transport of artillery pieces required either elephants or bullocks, and the roads were very, very poor in the Indian subcontinent at that time, obviously. But rockets could be carried by regular soldiers. So there was a state of Mysore in the center of India. This is roughly where Bangalore is today. It's and the capital actually of the state, Mysuru, is still there. The ruler of this state established a very large rocketeer force. What I'm trying to make a point that it was not just a small development, it was a large-scale development. So there was a 1,200 men strong rocketeer force, and his son, Hyder Ali, or Hyder Ali's son, Tipu Sultan, expanded this force to 5,000 men. What is important that the Chinese rockets were very small because case or cases in which they put this black powder and burn. The cases were made out of multiple layers of glued paper. Obviously, you couldn't have a large pressure inside. Therefore, rockets were relatively small. The Indians, again, this is an indigenous development, they introduced metal cylinders. It's from soft iron to contain the black powder. Immediately, you could have a bigger pressure inside. The rockets could be heavier and fly higher. And indeed, Indian rockets, and this is the end of the 18th century, Indian rockets had mass up to 12 pounds and a range 1.5 miles, more than 2 kilometers. The rockets still remained rather inaccurate and unpredictable. At that time, late 18th century, the British troops fought with Mysore, and they finally subdued all resistance and took over India by 1800. There were two major battles in 1792 and 1799, where the British troops faced a very heavy rocket fire by Tipu Sultan's forces. These battles of Seringapatam, or Seringapatna, as it is called today in India. And when the British actually captured Seringapatam in 1799 and the Tipu Sultan was killed there, they captured almost 10,000 rockets in storage. Just think about this again. It's not a few craftsmen that were making them. 10,000. It's a massive production. The British paid very serious attention to this rocket technology, and the reason was that at that time there was a growing competition between the rising Napoleonic France and the United Kingdom in Europe, and the war was imminent on the horizon. And as always, wars provided a major encouragement for advancing of technology and the development, and the funding appears and all that. There was a British inventor, William Congreve, shown on the right, who in the early 1800s got support of the British War Department, and he developed a family of rockets for the Army and for the Navy. It would be a first system of rockets really in the world. In a moment, we will see why. And these rockets, the first British Navy used in 1806, attacking Boulogne, and then in 1807, the British Navy burned down Copenhagen, the capital of Denmark, to the ground using these rockets. The rockets became known as the Congreves. And the rocket consisted, if you look on the top, of a warhead and then gunpowder grain in a case. There was a base plate with an opening, a nozzle, you could think, and a guiding stick attached to the side of this projectile. So what Congreve did, he developed a family of rockets of varying sizes. And the sizes varied from 6 pounds to 300 pounds, 150 kilograms. And this was a family of rockets with interchangeable parts, standardized parts, interchangeable. Tools were developed to service them. Different kind of warheads were developed. And even there was a flares could be launched that would be going down on a small parachute and illuminating area. In the National Air and Space Museum in Washington, you can see 100-pound Congreve rocket shown on the right. The rockets were widely used by the British Armed Forces, both for the Navy and the Army. If you look at the top, there's a naval British ship fires rockets. They were very effective against wooden shipping. And the wooden ships also carried sails, so it was a very good targets for incendiary weapons. On the bottom right shows that the British Army ground troops using rockets. One of the most important things about rockets is that they do not cause recoil. If you put a an artillery cannon on a small boat and fire a shot, there's a very good chance that the boat would capsize. Rockets don't provide recoil, so you can fire rockets from a small boat with the flat bottom, and the boat will not be affected. You need to protect the crew, as shown on the right. So the result of that, the British were able to put rockets on the small boats, and which opened the shallow coastal waters for the British Navy to come to the shore and provide support that artillery would have provided. Naval artillery would have provided, but they couldn't do it because the regular naval ships couldn't go into shallow waters. And also such boats, rocket boats, could go to the rivers. So it extended the reach of the firepower. Interestingly, that the same reason, a lack of recoil, led to the introduction of rockets on the airplanes. During World War I, many thousands of airplanes were built and operated by belligerent powers. And the airplanes were flimsy. When the pilot fired a machine gun from the plane was vibrating and trembling, and one couldn't increase the caliber of the projectiles because if you put a small cannon, the plane would disintegrate. So the rockets could be used because they don't have recoil, and this is exactly what the French Air Force did in 1916 at the Battle of Verdun. The first rockets were used from the airplanes. This was also the time when the guiding stick moved from the side of the projectile, as we showed here, from being attached to the side to the center, became axial. The base plate was made a little bit more complex. The central opening was for threaded with threads to screw a guiding stick in, and the holes on the periphery were now used to let hot gases get out and accelerate the rocket. This was a major improvement because when you have a guiding stick on the side of the projectile, you could only fire from a trough, such a device. And with the axially mounted guiding stick, you can fire it from a tube. So the accuracy improved dramatically. 1812. The war between the United States and the United Kingdom, the British troops widely using rockets in the European warfare against Napoleon, including Battle of Waterloo, by the way. So the British troops brought rockets to North America. First, the British Navy burned a number of the coastal towns in New England using rockets, as shown on the left. And in 1814, the British troops are moving towards Washington, D.C. There was a Battle of Bladensburg in August. And by a blunder, 3 Baltimore militia regiments were put in the wrong positions. British fired the Congreve rockets, and the regiments dispersed and fled. And the road to Washington, D.C. got open, and the same day the British troops captured Washington and burned the president's house, the Congress, and the bridge across the Potomac destroyed. 2 weeks later, the British tried to get to Baltimore, and the British Navy wanted to move towards Baltimore Harbor and bombard it, and the Fort McHenry protected the axis. So the fort was attacked, and the British developed even a special rocket ships. Actually, William Congreve was behind this. And one of such specially designed rocket ships, HMS Erebus, was brought in and attacked Fort McHenry by rockets. The American troops shot back with artillery and actually damaged this rocket ship during the fight. In a famous historical episode, Francis Scott Key observed this bombardment of Fort McHenry, and he wrote his famous verse that became the national anthem of the United States later. So when we hear in the rockets red glare, these are the Congreve rockets shot by HMS Erebus at Fort McHenry. The war was over, and what was happening in the United States in terms of rocketry? We already know that the British heavily used them in the European warfare, in Spain, in Waterloo, and against Napoleon troops, and also in North America. The Ordnance Department of the US Army experimented a little bit, but on a very low scale. And finally, a new war broke out, the war with Mexico in 1846. And again, a war provides major incentive to advance technology. There was another British inventor, William Hale, at that time, who actually improved the Congreve rockets. He made an invention. He said, let me remove the guiding stick from the rocket on the right, shown it's a contemporary drawing, and the openings on the periphery, rather make them aligned along the axis of the projectile, let me tilt them a little bit. So the exiting gases will not only accelerate the projectile, but also spin it up. And the spinning projectile would have some stability in flight. You don't need a guiding stick. It's a major invention. William Hale goes to British bureaucracy, and they say, well, no, we are not interested. So he takes his invention across the Atlantic Ocean, and then the US war with Mexico started. And both the Navy, the United States Navy, and the Army, both got interested. They bought his invention, did testing, build experimental prototypes at the Washington Arsenal. It's almost in the downtown of DC, close to the NRL, the Naval Research Lab today. Actually, I think the War College is there now on the premises of the Arsenal. And they built within half a year 2,000 new Hale rockets. This was also the time when the United States Army formed the first missile unit in its history. It was known as the Howitzer and Rocket Battery, armed with howitzers like horse artillery, like artillery, and rockets. And this company, this battery, joined the expeditionary force that went to Mexico and landed near Veracruz. And during the siege of Veracruz, actually, the Mexican troops first attacked the Americans with their Congreve rockets, and the United States Army responded with its Congreves and the Hales. So this Hale invented rockets became known as the Hales. So the Congreves and the Hales. And the rockets were used during the Mexican campaign until the end. After that, not much attention is paid to rocketry, and during the Civil War, they were used on a very, very small scale. And the reason was they deteriorated in storage, became unreliable. There were a lot of accidents, injuries by the troops that servicing them. So there was not much. The military brass wasn't happy with rocketry. Let's get back to the Congreve. So the Napoleonic Wars are over, and many, many countries jumped and started to develop rockets that they observed during the wars with Napoleon. The Congreve rocket designs were the basis for the proliferation of rocket technologies, the second wave of proliferation in the 19th century. The map shows the countries with the major rocket establishments. It's large red spots, and the small blue spots are the countries with the minor rocket establishments doing that. A lot of countries, particularly in Europe, were heavily involved in rocketry. It's the Russian Empire, Sweden, Austrian Empire, the French, the British, Switzerland, so had a major effort in the rocketry at that time. And again, these were the Congreve type rockets. What is interesting that the first country on the large scale tried to build a lot of rockets and use in warfare was Chile in 1819. And Chile was just liberated from Spain, only 1 or 2 years of age as an independent country, still fighting against the Spanish troops that tried to restore Spanish Empire in South America. And the Chilenos, or Chilean Armada, the Navy, built 1,000 rockets, and the Chilean Navy attacked Spanish shipping in Callao. It's a port close to Lima, Peru. The British and the Russians employed rockets throughout the 19th century in the colonial wars, sometimes very successfully in a very remote places with the poor logistics. Again, rockets could be easily transported on the backs of the soldiers or on the mules. And as we mentioned, the rockets could be placed on the flat boats because they don't have recoil, providing artillery support in the shallow waters. And the figure on the bottom left shows the British Navy attacking the Russian defenses on the shore at the Azov Sea, that everybody now knows because of the Russian-Ukrainian war. This geography is again in the focus. So this was during the Crimean War of 1853-56. So it's again very widely used rockets as a supplement or replacement of artillery where artillery couldn't get in. During the 19th century, a lot of technological advances were in rocketry. We already mentioned centrally mounted stick, rocket spin for stabilizations, fins for stabilization were tried. What William Hale also did, he introduced a hydrostatic press to ram black powder into rocket cases. If you think about this, if you use a wooden hammers, mallets, you wouldn't get high pressure to press black powder inside a rocket case. Also, from one rocket to another, there will be non-uniformity, there will be not the same density of the pressed propellant, solid propellant. So hydrostatic presses significantly increase the density and uniformity of the production of rockets. Also, when people used either mallets or monkeys, and monkey is simply a piece of wood that you will drop from a given height, say 3 feet, 2 feet, or 4 feet, they will hit the surface with the same force. So such wooden monkeys were used to, again, press the gunpowder into the cases with the constant force. When you do that, you create a lot of dust particles of the gunpowder mixed with the air, which is very explosive, and the devastating explosions on the rocket production factories were not uncommon. A number of workers were injured and killed in such accidents. So hydrostatic press was a major improvement. And also there was another very interesting development that became known only in the very late 19th century because it was so secret. The Russian Navy, Imperial Navy, in 1834 developed a submarine which was 20 feet long and carried a crew of 10 sailors, and it could shoot a few rockets from a submerged position. Again, this was a top secret development, and then it was in the secret establishment that was enforcing secrecy. It was so protected that the knowledge of that basically disappeared and nobody knew, and the military even didn't use it. Only the very late 19th century, the information about this development came to the surface again. All right. With all this story about rockets in the 19th century and successes and occasional use in warfare, by the end of the 19th century, rockets disappeared. Military lost completely interest, and the rockets remained only in the entertainment. Fireworks in the whaling industry used rocket-propelled harpoons. Why artillery completely overran rocketry for the military purposes? There was three technological developments that caused that. At first, the technology of rifling barrels, which allowed spinning up projectiles shot from cannons, and this improved the accuracy of artillery. Then the breech loading was introduced that improved firing rate in contrast to the muzzle loading practice before. And finally, development of the Bessemer steel, which was much stronger than a regular iron, led to the stronger barrels, increased gas pressure inside. That means a larger projectile and increased range. And also for the Navy, since the wooden shipping was replaced now by the ships covered by armor and no sails, rockets became really harmless for them, the Congreve type rockets. As the military stepped aside, writers became very important in keeping public imagination about rocketry and spaceflight alive. Actually, for a few centuries, going to other planets, which we would call a space flight or flying to the sun, were parts of the stories by many writers, and in such different countries as Firdausi in Persia, Lucian, Johannes Kepler of the Kepler's Law also had a science fiction story, and the French, de Bergerac, and such English-speaking authors like Daniel Defoe and Edgar Poe also had such stories, but nobody did more in promoting idea of spaceflight and rocketry than the French Jules Verne, or Jules Verne, particularly his famous story From the Earth to the Moon. And Jules Verne's novels were read by a large number of the young people, teenagers and children who would become the pioneers of the space age. If you look through the personal biographies, all these pioneers as Tsiolkovsky, Goddard, Oberth, Snow-Peltier, von Braun, Glushko, Korolev, all of them grew up reading Jules Verne's books. What is interesting, we mentioned that writers used the stories of space flight for sending their characters, but not for practical purposes. It was maybe a bet among friends. And it was until 1870 when Edward Everett Hale, a very inventive American author, published a story called The Brick Moon. Hale lived in Massachusetts, and a number of people were involved in maritime commerce or sailing, and many of them perished in the sea due to the problems with navigation. So he said, if we have a moon, natural moon, approximately in the equatorial orbit, and observing it, the sailors could determine their latitude. Why don't we launch an artificial moon over a polar orbit, and then observing that moon from the ground, well, from the sea, you should be able to determine your longitude. So enough characters in his story build this moon out of bricks, and by some mishap, it was flung into orbit with the people trapped on top of that to a polar orbit, which is along the Greenwich meridian. And nobody knew about precession of orbits at that time. At least Hale didn't know that the orbit would precess. So there was the first artificial satellite for practical purposes. And the sculpture of Edward Everett Hale on the previous pages at the Boston Commons, you can see that. So then the first great space pioneers stepped in, and they came from the 4 different countries, completely different stories. They contributed in a different ways, but in a complementary ways, advancing the idea of the space flight. There was the Russian Konstantin Tsiolkovsky. His visionary writings inspired a lot of space enthusiasts. There was a French Robert Esnault-Peltry. He was an aviation pioneer, actually an inventor of a joystick and ailerons and safety belts. Because he was a famous aviation pioneer, he had a lot of credibility, and he helped to bring the idea of spaceflight and rocketry into the mainstream science. If you think about this, in the early 20th century, if you talk about rocketry or going to the moon, you must be a nut. You must be an insane. So because it was Robert Snow-Peltry, a famous pioneer, aviation pioneer, he had a credibility, so it was became a mainstream, and he was the one who introduced the word astronautics into the language of science and engineering. Then Robert Goddard, with a PhD in a solid state physics, did a lot of theoretical and experimental work, and the first liquid rocket was that he built. And then the German Hermann Oberth published a very influential book in 1923, where he introduced many important concepts in propulsion and rocketry and spacecraft, and again inspired a lot of next generation of scientists and engineers. Robert Goddard, as we mentioned, built the first liquid rocket, tiny rocket shown on the right, the famous iconic photo that flew only several dozens of feet. Also, there was some not very pleasant story when in 1920, when he published a technical report where he described the rockets can be used to go to the moon. He was attacked by the New York Times, and then and other legacy media, as we would say today, joined in this attack, attacking his integrity, that he basically saying that he was a fraud if he thought that the rockets could work in a vacuum. And this was hurt him personally very badly. He became highly seclusive and did not interact with the other American rocketeers that started to work in this field in the late 1920s and 1930s. He actually moved to Roswell in New Mexico in 1930s, and he filed and he had more than 200 patents related to rocketry and satellites. And in 1937, his rocket that he built with a couple of assistants reached almost 10,000 feet in altitude. And again, he did not interact with American rocketeers. Again, it was the result of this 1920 personal attack against him. And most of the stuff that he invented and developed would have to be reinvented by others. And then during World War II, the first modern rocket appears, A4 or V2, developed by the German army, led by an artillery officer, Walter Dornberger, and the young scientist and engineer, Werner von Braun. This was a true technological marvel. It was 12.5 metric ton rocket, 45 feet high, shown on the right compared to a man standing next to that. It could deliver a warhead of 2,000 pounds, almost 200 miles. It was not very accurate, but could attack large areas. Its specific impulse of its engine, the sea level was 210 seconds. And what is important, the Germans succeeded during the World War II and constant aerial bombardment by the Allies to build almost 6,000 of these very complex rockets, and 3,000 were fired operationally against Allied targets in Great Britain and France and other places. In the United States during World War II, the rocketry was also being developed, and actually the very first steps were done for the military purposes. It was known as the JATO, jet-assisted takeoff, small rocket engines attached to the aircraft to allow a heavy aircraft to lift off from a shorter runways. And what was very important, this is very American feature compared to other countries that developing rocketry at the time, Germany and the Soviet Union and France later. In the United States, it was not only the state effort, but the private companies appeared. The first rocket private company, Reaction Motors, appeared in December of 1941. And then later it was folded into Thiokol and others. And aerospace engineering was formed in 1942, and the name exists today. The Air Force supported rocketry, and the General Henry Hap Arnold, the commander of the US Air Forces, was very proactive, and a group at the Caltech under Theodore von Karman did a lot of work and actually started the aerojet engineering, and this group led to the development or formation of Jet Propulsion Laboratory in 1943-44. Also, the Navy supported some rockets, and in 1944 and 45, solid propellant rockets were used on a very large scale as a barrage weapons, as shown in the photos on the bottom, helping attacking the beaches where before the either army units or marines were landing. So it was again on a very large scale, a lot of productions, hundreds of millions of dollars were of rockets were produced. The solid propellant rockets were produced. People sometimes say, why didn't we launch satellites in 1930s, maybe 1940s? A lot of technology were not there yet. If you think about this, the first radio telemetry or transmission of data by radio was demonstrated in 1932 first. Solar cells appeared only by mid-1950s. They were invented. Also, for onboard propulsion was needed, like cold jets and the hydrogen were developed really only in the early 1960s. And also, going to space required very large rockets, which required a large testing ranges, and Cape Canaveral was activated only in 1949. And the Soviet Union activated started to build its launch site that would become known as Baikonur or Tyuratam missile range in 1955. At that time, after the World War II, the Soviet Union and the United States, two superpowers in the post-war world, continued to develop ballistic missiles with the increasing capabilities in accuracy, range, and payload. In addition, scientists began to actively promote use of rockets for research of geospace, as we will call it today, upper atmosphere, ionosphere, and perhaps even looking at the sun or other stars in X-rays and extreme ultraviolet and other spectral bands. The scientific community worldwide came to the International Geophysical Year that lasted actually 18 months from July 57 to 58 to do simultaneous measurements in the environment of the Earth, to study our Earth as a planet. And 70 countries participated in the International Geophysical Year, and both the United States and the Soviet Union announced that they will launch artificial satellites to contribute to such study. So now we're getting to the first satellites going to space. So in the Soviet Union, it was a pure outgrowing of the Intercontinental Ballistic Missile Program, R7, which started in 1950 and became national priority and led to the first launch of this ICBM R7 on the full range in August 1957. And then 6 weeks later, on October 4, 1957, it put into orbit Sputnik, the first artificial satellite. Two people that are behind that should be identified are Sergei Korolev, top right. He was the design bureau, built the first ICBM, first space launcher, first Sputnik, first cosmonaut Gagarin, later first reconnaissance satellite. But his rockets were powered by the rocket engines that were needed, and these rocket engines were developed by Valentin Glushko at the bottom shown. And so these two people led to the Sputnik with this famous beep, 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 beep. What was happening in the United States? The United States Army, where the group of Werner von Braun and led by General John Meadows, could have wanted to launch satellites. They were behind the intermediate range ballistic missile Redstone, and the Air Force was working on a highly capable ICBM Atlas, could have done it. But Eisenhower said no to them. Eisenhower was a very frugal president. He didn't want an arms race with the Soviets. He didn't spend more money than needed for the national security. And in the United States, you could find out about military 80% or 90% of information about military programs, reading newspapers or going to congressional hearings. The opponent, the Soviet Union and the People's Republic of China, were closed totalitarian communist societies. Everything is secret there. You don't know whether weapons they have, how many divisions they have, and all that. So what do? Eisenhower wanted to establish a peacetime overhead reconnaissance to fly over, take pictures, and understand the intentions and capabilities of the country from that. However, the growing air defense capabilities assured that the airplane intrusions will end soon. And indeed, the American U-2 reconnaissance program of the planes, U-2 planes, stopped overflights of the Soviet Union in 1960 after the U-2 plane was shot down. Space reconnaissance was needed, said Eisenhower. However, there was a big problem at the time that nobody knew that is it legal to overfly another country? That is known as the freedom of space, the concept. Is it legal or not? So Eisenhower said, let's build an International Geophysical Year is a perfect opportunity. Let's build a pure scientific satellite on a pure scientific rocket launcher that is not a weapon. Fly this satellite and demonstrate that, yeah, we can overfly the other countries, and then we can bring satellite reconnaissance. That's why he said no to the Army and the Air Force and established a completely separate program, which is known as Vanguard, to build a new rocket that is not military in any sense and launch a scientific satellite. So the sequence of events. In 1956, United States Army, von Braun, could have placed a satellite in orbit. They had one of the tests of the Jupiter-C rocket, and they could have modified it to place a satellite, but the Washington said no, ordered not to do it. Then the Soviets launched Sputnik in October 1957, and then 1 month later, Sputnik 2 with a dog Laika goes on board. Big satellite, there's a tremendous uproar in the world. It's a danger. The Soviet Union can launch a satellite, they can launch an ICBM. And the American program is not there yet because Vanguard was not developed by that time, and there was some spectacular actually explosion during experimental launch in December of 1957. So at that moment, Eisenhower tells to the United States Army, von Braun, you can also join this race to launch an American satellite in response. And yes, indeed, in January 1958, the first American satellite, Explorer 1, launched. And this iconic photo on the top with the William Pickering, JPL director, Jim Van Allen of Van Allen Bells, and Vernon von Braun on the right. Then in March, Vanguard 1 launched successfully. And in December, Atlas launches a satellite, the first communication satellite, SCORE, actually. Now, for the record, there was Vanguard program was maligned by many people, attacked it. They had traitors even calling them. They were lost space race to the Russians because of you. This is very unfair what media did to Vanguard. If you think about this, the successful launch of Vanguard in March of 1958 was 30 months, 2.5 years after the vehicle authorization. In 2.5 years to develop a new vehicle and launch it. It's a major, major success on a very high rate development. So simply it was bad timing for Vanguard and the decision in Washington not to use the army. So the Vanguard should not be blamed for that. On the left, to scale, Vanguard 1, Sputnik, and Explorer 1, these first three satellites. And the question immediately comes, was there a technological gap? And if you think about this, the Soviet Union launched in October 1957. Within 14 months, the United States launched 3 satellites on the 3 different launchers on the rockets. That means 3 different teams of prime contractors in industry. So the technological base was there. There was no urgency or focus of a national program. So you cannot really talk about any gap or technological gap between the two countries. They were roughly on the same level. And if you look at the rockets that launched the first satellite, you can immediately see that the Vanguard on the top right is a flimsy, tiny rocket compared to the Soviet R7 that put the first satellite on the left. Atlas and Jupiter C that launched Explorer is in between. So why R7 is that bigger? And this is explained that the nuclear warhead technology in the United States was a few years ahead of the Soviet at that time. So the American nuclear weapons were lighter and smaller, and the Soviets, in order to build an ICBM for their nuclear weapons, had to have a much bigger space launcher. So R7 is much bigger, and R7 developed in a very successful launch family, Soyuz. And a few weeks ago, there was actually 2000 Soyuz was launched to the International Space Station. So it's a very successful launch system. In the beginning of the space age, figure on the left, rocket launches were not really successful very often. If you see, the success rate is about 50% during the first 3 years, and then black parts of the boxes are failures and gray are successes. So then success rate obviously improves. And there was a very spectacular failures during the launch, Titan on the top. I don't know how the videos are reproduced on Zoom, sometimes not very good, but I'm still running a few seconds. And there were also in the early space age a number of tragedies at the bottom. The biggest accident at that time in the Soviet Union in 1960, when almost 100 people died as a result of this very spectacular explosion at Baikonur or Tyuratam. Again, I'm not sure whether the videos are being reproduced by Zoom, but it's only a few seconds. So finally, after the launches by the Soviet Union and the United States, France launches its satellite from Algiers in 1965. Then in 1970, Japan and China launched their satellites. UK follows in 1971 from Woomera in Australia. After that, the European countries stopped independent development, combined their forces in the European Space Agency, and the first Ariane goes up in 1979. India launches its satellite in 1980, Israel in 1988, Iran in 2009, and North and South Korea in 2012 and 2013. Brazil tried a few times, not successfully, and in 2003, actually, there was a major accident that killed 21 engineers and technicians on the launch pad. So this was the time that I was describing, when only such a powerful entities as national states with their resources and mobilizing industry could achieve launch to space. Today the situation changed. We have a number of truly commercial companies that could do it basically in any industrial developed country. They could build a space launcher and put satellite in orbit. And as you know, a number of the space launch companies growing very rapidly. So the first 1,000 years of rocketry brought us spectacular successes, and we reached the cosmos. And the next 1,000 years will be even more exciting, although I'm not sure we will reach Alpha Centauri, but who knows? But nobody said that the road to Alpha Centauri would be easy. So per aspera ad astra, through difficulties to the stars. Thank you for your attention.
Wow. Thank you so much, Mike. This is great.
I stopped sharing.
Yeah, I see that. And I did not see any questions. So for those that attending,
And
if you
people,
have any questions, please, you're welcome to unmute. I'm going to stop recording so then we can just continue conversation.